So I'm Kelly Stettner. I work on the Black River down here in Windsor County, Vermont. We're an all-volunteer group, and so we do what we can with what we have, building a lot of partnerships and seeking a lot of creative solutions to things. Phragmites. What is Phragmites? It is a tall grass, but there are a lot of other tall grasses, lots of other rushes, reeds, so I'm just going to call it Phragmites. It can grow extremely dense very quickly. Some of the threats that are posed by it include habitat loss from monoculture. The stand in this photo is actually fairly thin compared to some of the really monstrous ones I've seen. Let's see, it also decreases property values for obvious reasons, impairs recreation for obvious reasons, and it can actually cause infrastructure problems and economic loss because it can clog ditches and sewage ponds, impair visibility if it's on the sides of roads. I don't think, like knotweed, that it can bust through pavement, thank God, but it's definitely not a happy plant that you want to see in your community. It features a tall single stalk with leaves coming off from the shaft itself like a corn stalk. It can get extremely tall, and a lot of the times you'll find it growing in water, standing water. It's usually not on a fast flowing river that I've seen, but if the stand is strong enough, it can certainly take over a bank. But the stalk tends to be green up above and then tan toward the bottom where it meets the water. There is an American Phragmites, and there are ways to tell the difference, but I didn't want to get into that today. The stalks are hollow. They're more rigid than knotweed, pardon me, and they actually can be used for things. So not really, more for thatching rather than for building material. They have thick, hollow rhizomes that can be many feet long. They're like a tube, and they can go under the water. They're in the muck. This stuff is really hard to dig out successfully. They also send out overland stolons like a lot of grasses do, and you'll see a slide later on with a volunteer holding one of those up. And the underwater rhizomes act sort of like a snorkel for the aerial stalks that they pop up. Phragmites also features a feathery plume, which is full of seeds. That usually appears into late summer, early autumn, and persists often right through the winter. They can be tan or they can be a purple, a really deep purple. So the reason I'm interested in Phragmites is because in my watershed, way up by the headwaters of the Black River in Plymouth, Vermont, is the first of a series of lakes that are in a chain formed by the Black River itself. And this one is it's Amherst Lake. If I move my mouse around, can you guys see my pointer?
Yeah, Kelly.
Okay, good. My apologies for the traditional every single morning clearing my throat. Sorry. So we do have a public boat ramp on Amherst Lake. Sorry, and the river itself comes down, runs parallel with Route 100, comes down in and enters the lake at the northern end, runs all the way through a couple of very deep holes, and then exits way down here at the southern end of the lake where there is a man-made dam. Now, that dam is in the process of it's been evaluated. It's a significant hazard. It's not in good condition. There is a concerted effort by a very, very new lake association to attempt to find funding to redesign and rebuild that dam to maintain their lake levels. But it's very, very possible, very likely that the dam is going to actually go away. And of course, that kind of polarized all of the landowners. Oh my goodness. The loss of the dam and the dropping of the lake level polarized the lake owners into what do we do? How are we gonna handle this? Especially around the northern end where the lake levels you can see are 1, 2, 3, maybe 4 feet deep up in here. If that dam goes away, the new shoreline is going to be about 500 to 550 feet of mud, and Well, right now, Phragmites. There is some cattails. There are some native rushes up in here, but there's a nice, healthy stand of Phragmites right in that northern cove. Um, so that's the main reason that I became involved, is because I wanted to start doing a vegetation survey of the lake to see what's here, what do we need to deal with, what do we want to promote. Let's do something positive that we can get the landowners involved in so that they're more engaged in the lake and thinking about it in the long term. You know, what's here, what's going to happen to this lake if the dam goes away. So here's kind of a real life view of that cove. You can see the river coming in over here on the right. We got a house up here on just on the peninsula, and another house right over here close to what is actually the boat landing, the public boat landing. And this, I had a friend with a drone who came in, Windsor County Drone Services, big shout out. And he took some nice aerial shots and footage up high and then down in low, so we could actually see along the coastline what's here. And I got out in my kayak, my nice folding origami kayak, so I could get right up in close and personal and check things out, take pictures, started an iNaturalist project so that we could really maintain the observations for years to come. And the Phragmites stands that we're looking at in this slideshow are right here by this big, everything's relative, by this little marina, which is basically a couple of paddle boats, a couple of pedal bikes, that sort of thing. And then over here it continues on much thinner, but it continues on almost in woodland cover by the Andrews house up here. There's a much larger stand around this corner, but we didn't get that far. We wanted to start at the marina. Very visible, very accessible. People walking along the road could see what we were doing and ask questions and get involved. It was definitely more of an impactful site to start tackling right here. It's also the beginning of the Phragmites, so we could start here and work our way around. The shallow northern cove, it does provide habitat for, there's a lot of little fish up in there, many different species, salamanders, turtles, frogs, dragonflies, and this beautiful little osprey who came in for a snack while I was taking pictures of the Phragmites. So it does have definite benefit having that shallow cove there. And this is how we found it in July. I had just arranged the first volunteer cutting session in July. And this was before anybody got out there with tools to start working. So here we are standing on the dock of that marina. The little dirt road is around behind us to the left. And this is the beginning of the Phragmites. And we're going to work all the way around under those trees. It's about 100 feet long by maybe 20, 25 feet, goes back up into the woods a bit. So what is that, around 250, 300 square feet? There are some native cattails in here as well, and we were very careful to identify those and leave them alone. And this was after, so before and after. I have process pictures, but I kind of like the immediate, wow, look what you guys did. So we had about 14 people show up, including one lady who was just driving by on her bicycle and decided to stop and help. People got mucky. They got right up to their mid-thigh in the water and the mud, and you can see all the algae stuff out here. It was a very successful day in getting all of this stuff out of there, and I'll get into what we did with it. And you can see some of these native rush type plants, and there are some small cattails in there as well. And this is everybody at work, lugging stuff, hauling stuff. More hauling and lugging. They did so much work. It took us maybe an hour and a half to clear that entire patch with 14 people working methodically. And these guys own the little house that's out on the peninsula, Don and Ann. And Don brought out his electric hedge trimmer, charged up the battery overnight. And this was probably the best reason that it only took us an hour and a half, because he went through and cut. There was somebody right behind him gathering, and somebody else taking those armfuls and pulling them off onto the shore to make piles. We made neat, concise piles. It wasn't a windy day. Any piece, just like knotweed, any piece or chunk that has a node can can reroot, can just send out shoots and just get going. So if it's anywhere near the water and a piece just floats away from you, it can start a whole new colony. So we made sure to get these piles up away from the water. We loaded them right into pickup trucks and moved them just across the road to Alicia's house, the lady who lives right by the boat landing. So she stored this all out back of her property I think she had it on either pallets or cardboard, thick cardboard, and she just laid it all out to dry. As soon as it's dry, it's dead. I think she did a burn after a little while and just got rid of it. And there's one of those stolons. You can see the all the roots coming off of that thing that was heading for the water, but most of those what look like vertical roots right now because of the way he's holding it, those were all on ground, on dry land. So from this is what it looked like in mid-August. So we did our cut in July, and about a month later I came back and this is what it looked like. So we had a little bit of green regrowth coming up. We left it high, about 6 to 8 inches tall, because we wanted to see the regrowth so we knew where to cut next. So we did manual cutting, and oh, that's right, I had my drone guy there too, so he got a nice aerial shot of what it looked like after we'd cleared. That's still in August though. So about a month after we did our cut. And so we went back in September and tackled what had regrown close to the water and started spading. And I've been talking with a lady from the Manitoulin Phragmites project up in Canada about how she deals with this stuff. She does an herbicide approach. We're not doing that as a volunteer group. The town might be doing that. If I need to get talking with them about the upriver Phragmites that's feeding the downstream sites. But this is one of those big underground tube-like rhizomes with the tall stalk coming off of it. And we only had 4 of us working, so we didn't get extremely far that day. Kids were back to school. It was hard to get volunteers to come back out, end of summer and all. But the spading technique was to go up to each stalk and lower in a pointy spade, and just pop or snap into the underground rhizome so that it would basically flood it, because it's a hollow tube. So we were essentially cutting off the plant's air supply. So we did as much as we could. We did about a third of what we had done in July. The 4 of us were able to get spaded, and we pulled some, obviously, as you can see, but we didn't do a big harvest in September. And then I went back in November, and it still looked a lot better. This stuff out close to the water here, most of that is cattail, but we're seeing some more of the Phragmites coming back in the upland area. And a couple sprigs out here by the lonely canoes too. Let's see, there's a small, and I'm almost done here, believe me. There's a small patch close to the boat ramp next to Route 100. We're probably going to be putting out some fundraising efforts to buy large black billboard vinyl, and use it as tarps. I'm going to cut this down to the ground. Obviously, we can't spade here because of the big rocks, but we're going to tarp this site. It's about, I can't imagine more than, a 50 square foot tarp would do it. And there's another site further down on the eastern shore, very inaccessible, except by boat. So we may go in, cut this one. It's also, again, you can see all the rocks and the big logs and stuff. Big stolon heading right out into the water there. And we did collect that while we were out. But we're going to try tarping this one as well. It's almost the size of the northern shoreline stand. So that'll take a bigger tarp. And then this is that upland area on Route 100. This is I don't recall the mileage, but it's a little ways above the shore of Amherst Lake, but it's just a field of Phragmites. So that's the sort of thing that I may need to talk to the town about, potentially doing an herbicide treatment with a very, I'd like to find a reluctant herbicide applicator, someone who would be very, very strategic and judicious in the way they apply it. But essentially, persistence, positivity, and potluck picnics. That's Alicia collecting up a big armful of Phragmites, and she and her husband hosted a wonderful potluck on their shoreline right after we were all done in July with that big, massive cut. There is a couple, that's the last slide, but there's a couple of little notes there. We do have a plan in place if the dam goes in that huge 500-foot, it's going to be about maybe a 50 to 60 acre area of the northern shoreline that's going to go back to wetland. I do have some plans for native replanting, but we want to see what the seed bank looks like and see what starts growing up. And I'm helping that new lake association get started, and I'm partnering with downstream associations as well to look at more, Phragmites monitoring and management. And I'm also in the process of getting the ball rolling on a lake watershed action plan, probably next year, for all the lakes in that chain. And I would venture to say that Phragmites is going to be a big part of that. And that's all I got for now.
Thanks so much, Kelly. So we have time for just a couple of questions before we should move on to the next presenter. And it looks like Ron has a question and there's a question in the chat. So we'll start with Ron. Ron, go ahead.
Hey, Kelly.
Hey, Ron.
I say this a little bit tongue in cheek, and I hesitate to say it at all, but if the dam is removed, that may solve the Phragmites problem, because the size of the lake will shrink, right?
Yeah.
So that patch that you're treating would be essentially high and dry. And
I hear what you're saying, and my impression from talking with the wetlands folks is that the soil is going to maintain that profile for a while. And Phragmites can do okay on kind of dry land. The lady in Canada was talking about a patch that she found on like a gravel field. So I'm gonna hold off judgment on that one. I'm thinking it's probably gonna still be an ongoing thing.
Like I said, it was a little bit tongue in cheek.
Yeah, it would be great if that happened, but I think it's going to require, if nothing else, plenty of monitoring. Given that it's perennial, I have no idea what it's going to look like in 2022. I'm looking forward to going back in June. My bet is that it's going to be probably a 3 to 5 year process of continuing to cut and continuing to remove the material and continuing to spade and just break off the rhizomes, cut off their oxygen supply, and continue to promote natives that are on site.
How am I doing? Can you see my slideshow? Can you hear me? Perfect.
Yes and yes.
Okay. So I wanted to start with a little humor. So I've got my my drone that we're actually using to monitor Japanese knotweed, not kill it, but we can dream. So I thought I would bring in a laser gun, burning up some Japanese knotweed. And I'll come back to this at the end, but today I want to talk to you about a project that we're working on at Norwich University to monitor Japanese knotweed using aerial drones that are taking images, and then we're doing some processing of the images to be able to identify knotweed and really monitor its spread and where it is without having to trek across giant wetlands and other areas like that. And so before I keep going, I just want to say that this is a project that's part of a collective of researchers at Norwich University that call themselves the Dog River Conservancy. And that has been funded by the Lake Champlain Basin Program. So big thanks to that organization. And the Dog River Conservancy at Norwich University is working under the umbrella of the Center for Global Resilience and Security, which so Dog River Conservancy is like the local part of this, more globally minded group of researchers. Okay, so I want to talk about Japanese knotweed just very briefly. I'm sure you're all familiar, but I'm intimately familiar with it now. It's an aggressive colonizer of riverbanks, especially where there are places that flood often, and there's erosion. Maybe a big open patch of sand quickly fills with knotweed, that has washed downstream during the flood, right? So places along the river where there's frequent flooding, is those spots are really vulnerable to knotweed, and then it takes over and really grows in tall, dense stands, outcompetes native plants in the riparian buffer. It doesn't help with bank stabilization as much as, you know, a big diverse riparian buffer, and can actually sort of aggravate erosion, and it's really difficult to eradicate. So the project that I'm working on is centered on a municipal park that's fairly new in Northfield, Vermont. So I just wanted to give a little history of this park. So it's called the Dog River Park. And actually, it is a project that came out of Tropical Storm Irene, because the site that I'm showing you here, this park, was actually a pretty densely populated residential area with all in all, there were actually 14 houses on this site and adjacent sites that were all part of a FEMA buyout following Tropical Storm Irene. And those houses were demolished, and the land that those houses existed on, that's what you're looking at as that has been turned into a park. And so the really cool thing about this, I mean, that all that is tragic, and you know, it took out sort of one of the central residential areas of Northfield, Vermont, really close to downtown, like steps away from our square. But the really, you know, the plus side of this tragedy is that we get this ecological park really, really close to our town square. And so Michelle Braun was the town manager at the time that this happened. And I just have to give her a shout out because it's incredible. She already had a plan in place for what we might want to do with spaces like this if there was a large flood that led to a FEMA buyout or something like this. So then when it happened, it was like, well, I guess we should probably use this plan. And so the town was able to purchase the property and lower the elevation of this area and sort of reconnect it to the floodplain. So now when we have our spring floods, there's the water creeps into the park and you know, has a chance to slow down and drops sediment and drops debris that's floating around. You know, there are always new big giant logs that would have been rushing downstream after every flood. They're left behind in the park. So it's become an outdoor classroom. It's become a place for recreation. It's become a place where people get exercise and walk around and meet in this pavilion to have lunch. And it's great. It actually won an award, a Public Places Award from the Vermont Urban and Community Forestry Program in 2021. All right, so that's our site. As I mentioned, it is reconnected to the floodplain, and when it floods, there's a lot of sediment deposition and of course also a lot of knotweed deposition, right? So it's going to be a constant battle to keep the knotweed out of this park. And so now I want to talk about what we're doing with drones. So the engineering department at Norwich University approached the Dog River Conservancy with this project that was actually run by a student as a sort of a senior project. They programmed a drone to fly a pre-programmed route above the park, about 200 feet up in the air. So it's above trees and power lines and things like that, but close enough that it can get really high quality images. It took images, you know, every so often. And then all of those images are patched together using high-tech software, and then those images can be used to sense knotweed. And I'll go through the steps of how that was sensed, sort of the steps that have to be taken. But on the right, you're seeing an image where each patch of red is places that the software has predicted it, that's where knotweed is existing. And a lot of it is really accurate. For example, you can see along the bank of the river that's down into the right on my screen, there's a lot of red, and that's accurate. That is all knotweed. Another part of this, and this is really where I come in, I'm not an engineer. I am not a computer programmer. I'm not a drone pilot. I'm not even a plant researcher. I study fish, but I am good at getting people out into the field and leading lesson plans. So I worked with a local high school and junior high teacher, and her name's Cynthia Fortin, and she brought out some Northfield Middle School students, and we had a whole lesson plan designed where she had taught them how to identify it and all the problems with knotweed in the classroom. And then they came out and did an extensive survey of this park. It's a pretty small area, and there's a lot of kids there, as you can see. And they walked around with their little signs and their cell phones, and they used the cell phones to identify the latitude and longitude of places that had confirmed knotweed, had maybe like a little mix of knotweed and other plants, which you can see in the second image. That's a bunch of knotweed around the base of a tree. So from above, it's going to look like a tree. That's going to be a spot that's really impossible to see the knotweed when that tree is covered with leaves. And so they submitted all this latitude, longitude data so that we could use that to teach the software about locations that were actually knotweed and other places that were not knotweed. And so the third image is really a good example. The software is probably going to have a hard time with this third picture. That is actually not knotweed. It's just a bunch of maple leaves, but they look really similar to dried up knotweed leaves. So in the fall, maple tree leaves on the ground are going to be a problem for the software. But anyway, these are all great problems for an engineering student to work with. So we take the location of confirmed stands of knotweed, and we tell the software, this is definitely knotweed. Take a look at this particular part of the images and grab the color signature of the pixels in these places that we definitely know are knotweed, and then find all the other places in the image that have that same signature, and then predict that that's knotweed. And then we go back, and the software has identified pretty much all of the large stands of knotweed, but it's also identified some other things that are kind of similar to knotweed in color. And we go back and we try to find those using those ground truth data points given to us by the junior high students, and say, actually, we know for a fact that at this particular location, that is not knotweed. And so the software needs to figure out a way to differentiate those places that it's giving false positives. And then I just want to say, I'm really excited about this project. It's actually on hold right now because the professor in charge from engineering retired. And so it's on hold. So it's an open invitation, really. Like, if any of you are excited about this project, send me an email. You can take the reins, really. I mean, Norwich will support you for sure. And I'd be willing to explore like a technology transfer grant even, because this is technology that has a precedent in agriculture, right? So in agriculture, drones are being used to look for stressed plants because of heat stress or because they're drying out. Plants that are not actually crop plants, plants that need nutrients, right? And then the drone imagery is being fed into ground drones that are going around and giving fertilizer and pesticide if there's a known pest problem, or herbicide if it's a weed. And I guess I'm probably just not going to play the video for the sake of time. But I just want to give a final, I had this silly laser on my first slide, but actually lasers are indeed being used to get rid of weeds in agricultural fields. So it's actually not that far off from the truth. Probably wouldn't work on a riparian buffer though. That'd be bumpy for the drones. I think that's it. I think that's all I've got.
Great. Thank you so much, Simon. Really interesting. And I personally always love to see projects where students are coming in and helping to ground truth things, fun for them and also super useful for these kinds of things. Anyway, so we have time for, a few minutes of questions for Simon. If anybody has questions, you can drop them in the chat, or maybe even better, raise your hand and ask them with your voice.
Yeah, I actually have kind of a topic. Do you have a question yet? I guess
I don't see a question yet. So
okay, so I am stop sharing. There's a lot of Norwich property and town property upstream from this park, and I'm hatching this idea about how to start the process of getting the town and the college together to do a better job, because this park, we're doing a good job of controlling knotweed. Michelle Braun and the Friends of the Winooski River have really helped us, continue to maintain this park after its installation. But it is embarrassing how much knotweed there is upstream in the properties owned by Norwich University and the town of Northfield. And those are the real problems for this park. So if anybody's got ideas about where I should look for, a place to start that, a partner or a funding opportunity where I could start working with others to try and get some of this land conserved and restored and knotweed control in place, I would love to hear about that.
Yeah, thank you, Allison. I can just do a quick introduction, and then Bill's going to do the bulk of the presentation with some photographs. We got started with this idea because we had some non-traditional landowners and non-traditional planting locations and non-traditional philanthropists and funding sources that all kind of converged. So the planting sites are non-traditional in the sense that they're not agricultural settings. And so they're either upland settings where there is a fallow field, or there are areas where a forest was cleared for some reason, sometimes by a logger with poor practices, or sometimes because there was a monoculture of trees growing there that wasn't healthy. Also some wetland settings, and this year we'll try some riparian settings as well. So these are settings where the normal programs and normal partners aren't necessarily a good fit. At the same time, we had a couple of funding sources who were very interested in trying alternative methods of planting and alternative methods of herbaceous weed control. And so we started asking around, and so of course, Katie Kane, who seems to be involved in helping everybody with everything, was able to point us in the right direction. And we ended up talking to the folks at the Stroud Center, and they're just amazing people with a lot of great research going on. They were able to share with us some of their findings related to stone mulch. And so we decided we would give it a try. And so in addition to Katie, some of the other key partners in making these projects happen, as well as, of course, the landowners, Watersheds United, Friends of the Winooski River, Pure Projet, and a couple of foundations and anonymous individual donors who were particularly interested in methods that did not include the use of herbicide. So that's kind of how we got started with this. And in addition to being interested in finding methods of herbaceous control and methods to increase survival that don't use herbicide, some of the folks involved, have other objectives that, while we probably all share them, they aren't often front and center in how we explain the value of our work, because we're most often talking about water quality or habitat. But some of these folks are also interested in wildlife habitat in general in other settings other than riparian settings. They're also interested in carbon fixation and climate change preparedness. So that plays into what species we select for these sites. And so we're sometimes using some species that are native but are more common in points further south, with the idea that we're helping set the stage for the forest to adapt as the climate changes. So that's kind of the context for how we get started with this. And now I'll turn it over to Bill, and he can talk about what we learned from Stroud and what we did and where we're going to go from here.
Hey, thank you, Ben. That frames what we're after really nicely. And I'm going to try to share my screen here. Just PowerPoint. Now, can folks see the first slide here?
Yep.
You hear me all right? Okay, thank you. So like Ben said, we're talking about stone mulch, primarily as herbaceous weed control. And here's just a picture on the right of a red oak that we've applied stone mulch, and it looks like it was recently watered too. And that kind of goes into, you know, all of these, I just want to make clear from the start, all of these are upland sites that we actually have tested it on and have results from. So there were more species like red oak or maybe American hazelnut or, you know, just other more upland species that we tried this on. And we tried some hickories and we tried some walnut actually. Anyways, so that's a little bit of what it looks like. This is the stone material we're talking about. So I always would refer to it as hard pack or stay mat, but it's basically a maximum diameter and then all of the sizes of stone that are smaller down to the dust. So it packs tightly. And this is, like Ben said, this is all based on what we heard from the Stroud Research Center, and then we sort of adapted it to our goals and what we were trying to accomplish. So we have this stone and it's heavy. It's fairly cheap, the material. The delivery cost is most of the cost actually for this method. And then the labor is pretty similar to other methods. So, so we had the stone delivered to all these sites, and we had a tractor on site. And we just used 5-gallon buckets and shovels to move it around. Certain sites we could get pretty close to the stems and it went really well. Other sites were steep and sort of challenging terrain, challenging access. I'll talk about that a little bit more later. And then we used, so I don't have pictures of this, but I want to just show a prop if I can. These are pieces of 18-inch plastic culvert that, you know, we had talked about using 18 inches modeled after the research center, and I happened to find some scraps of culvert at the town garage, so it just worked out, and we found that was a nice method. So they're 2 inches thick and they're 18 inches in diameter, and we would just dump the stone right into those. We'd pop it over the stem, dump the stone into those, pull it off, and then pull the stone away from the stem, and then we also watered at all of these sites. Okay, so we don't really know, right? But this is from our communications with Stroud and what we understand about all of these dynamics. So I want to make it clear. So at Stroud, it was tested primarily as you know, along with other methods for vole protection, and the other methods were basically doing nothing or installing a vole guard or installing basically crushed stone that didn't include the smaller sizes. So there were a lot of spaces within it, and then what I would refer to as hard pack, or this crushed stone mulch. And I believe on most or all of their sites that they were mowing. And so certainly I guess one of the ideas was that this open exposed surface on the stone was a less favorable habitat and condition for voles to be in, more exposed to predators. And that's not necessarily how we're going to see that play out on our sites, because we're not mowing. Some places, I guess we might also be weed whacking. We haven't done both yet. But so we saw their research and we saw them testing it on as a method of vole protection, but we also saw their results on survival rate, and they were promising. And although it's a fairly small study, but I believe it was over tens of thousands of stems, and I think they monitored it over I think just the growing season after planting. So anyways, they were very focused on voles. We are most interested in it as an alternative to our other methods of weed control. So, you know, bark mulch or weed whacking or applying herbicide. And we also expect that it's providing some good moisture retention. We do wonder about the trade-off of evaporation, having that hot exposed stone pulling moisture, but in my understanding, it's so densely packed that I think the evaporation would be pretty superficial around the surface. And it seemed when we've pulled it back, you know, in the monitoring visits, it seemed to do a nice job actually at keeping the soil more moist below the stems. And the material it's just way cheaper than bark mulch. I guess the trade-off is it's heavy, but if you have good access, it's not a big deal. And like I said, yeah, the cost is comparable to when we apply herbicides. So from a cost perspective, it's a pretty much just a lateral move over. And okay, so these are slides. These are taken right from the Stroud research presentation that we looked at and that we discussed with the folks there. So just to quickly show, they had put tree tubes actually on all of their trees, and then also tried these other vole protection methods. And you can see the vole guard. I don't know if you can see my mouse. So you can see the vole guard at the top of the screen, and then they used, this is the crushed stone with all of the spaces in it, as opposed to the stuff I showed earlier that includes all sizes, which they are calling 2A modified stone. And these are right from Stroud as well. So, oh, and now I'm correcting myself, 4-year survival rates. So I was wrong. And you can see the 2A modified stone on the figure on the left, number C or C, yeah. So it was just over 75%, and that caught our attention. And then it did not seem to have a whole lot of effect on the growth, the height growth. So they got us interested. And oh, and here I forgot I put this in too. They had compared the growth and survival to some herbicide applications as well, and different diameters. And so it looks like the stone mulch, the growth and survival was quite similar. I actually can't, okay, yeah, it was quite similar across the board. So we decided to go with the larger diameter, the 18-inch diameter, and try that. So just some photos from the sites. These are all at different sites, and just showing the process. You know, the tractor's bringing that crushed stone. You can see it has a lot of really fine material in it, and hard work and a lot of labor, but the tractor really helps, and good access really helps. And just putting that plug in that with any sort of mulch, definitely important to pull it back away from the stem, improve circulation and reduce problems with moisture and all of that stuff. And I think the stone mulch also may sort of cook the stems if it's too close. So we made sure to pull it back, you know, a few inches in any direction. We watered them right after. So here's just showing, you know, the second phase, and pulling it from the brook, bringing it up to the site. And then the stone mulch actually serves as kind of a nice little bowl for the water to sit in and soak in, especially when you're planting on a slope. So we would pour the water in gently, and then we'd actually pull the stone back again just a little bit. And that's just some examples of what it looks like. A little tamarack. Kevin's planted an oak there, and you can see the water just sitting there and slowly infiltrating to the soil. And you can see it's pretty well packed. These are I just want to give folks an idea of what this looks like. So these were probably standing up on top of the tractor, taking pictures of these sites. So what we found, we did 3 upland sites in 2020, a little over 3,000 stems, and the survival rates when we monitored them, in 2021, I believe it was late summer, early fall. And we had similar survival results, a little bit higher than Stroud, and certainly high in general, from what we know and what we experience. That is only after 1 year. So it had 2020 and basically 2021 to grow. And some of these sites, there were favorable conditions, like really nice soil, or one site there was not a whole lot of herbaceous competition because it was pretty sandy, and the other plants just weren't thriving. So I think that was the 84% there was a site in Orange County where the competition was pretty low. And then last spring we did 1 upland site in the Winooski River watershed, I believe. And so we have not monitored that yet, but it looked really nice. I mean, that's a kind of a prime time, well-drained, moist loam upland site. And we chose species that were appropriate for the site, and it seemed to do very well. And just to show, so this is quickly, and I'm going to expect someone to yell at me, I guess, if I'm taking too much time, but I believe this is the same tree at one of the upland sites. You can see the asters, other herbaceous competition is coming up, and the stones seem to be doing a pretty good job at keeping it down just in that, in that little diameter, 18-inch diameter circle. And just to show some weed whacking alternative. So our plans for this spring, we have 3 sites and about 2,800 stems that we're trying it on. These 3 sites they're a mix of sort of old fields and recently cleared areas and wetland edges, and so it'll be interesting. If I had to categorize them, they're all upland sites, but there are certainly some wetland areas that we're getting into, and really similar materials and methods. I just want to say on that I think this really makes sense where you have good access, but if it makes sense at all, right, that it makes the most sense where you have good access and fairly gentle terrain. Certainly if you're lugging, the weight of the stone being the factor there. So when you're hiking up a steep hill for hundreds of feet with stone all day, it's pretty tiring. I want to just quickly acknowledge our partners again: Watersheds United Vermont, Friends of the Winooski River, Pure Projet, a couple of anonymous donors, U.S. Fish and Wildlife. Particularly, thank you, Katie Kane, for pointing us in this direction, and to the folks at Stroud Research Center who really kind of got the ball rolling and made us think about this stuff. So thanks, and we can take any questions if there's time.
Thank you so much, Bill. That was super interesting, and I know there's a lot of questions that people popped into the chat, so definitely take a look at that. We do have just a couple of minutes before we need to move on to the next session, but if anybody wanted to ask a question while we have Bill talking rather than typing, you can raise your hand, and then we can do that.
Okay.
I don't see any hands raised, so we could start with some of the questions in the chat before we run out of time. There was, I'm trying to find, there was a conversation about tree tubes, but I think that more or less got answered by others in the chat. And then
Okay.
there was a question, Ellen Fox asked, any concern about creating lots of semi-impermeable areas?
Yeah, I think that's definitely a good thing to consider. I would be most concerned about that on steeper slopes, and certainly if you were right along a waterway. You know, my understanding and sort of the way I've been thinking about the dynamic is that the area that is relatively impermeable is fairly small compared to you know, the herbaceous cover around it. So I think it's fairly minimal. That said, if those were to become sites on a really steep slope where erosion to begin, that would be a concern for sure. Basically what we tried to do on the steep slopes was to pull back the stone and create a berm on the downhill side, basically. So I can't answer that have a great answer for that question, but I believe it's pretty minimal effect.
Yeah, I can jump in on that, Bill, really quickly. There are a couple things that help. I think one is the shape of the stone, which Bill referred to there, but you know, you're actually taking rainfall that's occurring, that's coming down within the mulched area, and you're funneling it more or less into the base of the tree. So it's getting into the soil that way. And then you're also getting moisture moving in through the sides underneath where the stone is through the soil. So it was interesting thinking about this and talking to Stroud Center, and especially when you start to consider the larger crushed material versus this type of material that's got all the fines in it. And intuitively you would think, oh, it'd be better if you use the crush because the rain can get right through it. But actually using the fines, we're thinking we get just as much moisture, but we're also reducing the amount of evaporation that's occurring right around the stem. So as Bill said, when we've dug into a few of them afterward, it seems like the soil's retaining moisture pretty well in these situations.
Awesome. Okay, and we do have two questions. It looks from Ben Gabos and Chris Smith. I'm not sure we'll have time for both. Why don't we take Ben's question because it was first, and Chris, maybe you can type yours in the chat. Sorry.
Okay, we could do rock, paper, scissors. So that, I guess and this is no critique to you guys, Ben. I'm still kind of struggling to understand if voles are a real issue and you're using a tree tube, and I know you guys weren't. If the tree tube's seated in the ground 1 to 2 inches, why do you need stone? And maybe you don't have the answer to that because you weren't using tree tubes, but it seems unnecessary to me because the tube will protect from voles. And secondly, in most situations where we really would like to see control of competing herbaceous stuff, material nearby, I don't see the amount of stone that's being put down or prescribed by Stroud as being very effective, because once the grass gets up higher than the diameter of that, a lot of the reed canary situations, obviously that's not going to do much of anything.
Yeah,
that's it.
Yeah, I think I could speak to your second comment, Ben, and then maybe Bill can speak to your first question about voles, because that really wasn't our focus, but I know Bill spent quite a bit of time talking to the folks at Stroud, so he may have some insights on that. We haven't tried it in settings where there was reed canary grass, and I think it would be helpful, but I don't think it would solve the reed canary grass problem. Obviously, you could go wider, but as everybody knows, as you get wider with a circle, you just get so much more area that the labor may end up being the amount of material and the labor involved in getting that amount of material to every stem might end up being a challenge. On the other hand, a lot of those settings, the access is actually a little bit better than some of the settings we were planting in. So maybe it would be feasible. We still think that herbicide is a more practical solution in a lot of cases, but we also know there are situations where herbicide's not an option, even in agricultural settings, whether they be organic farms or preferences of the landowner. So yeah, I'm not sure how exactly to adapt it to that kind of setting. Then it would probably take some experimentation, and it might or might not work.
Yeah, and I'll just quickly make a comment about the voles. I'm not sure. They may have had problems with voles actually burrowing and finding their way into the tree tubes, which I've actually seen that as well. I think it's probably not widespread, but yeah, we certainly weren't looking at it as a vole protection method. That said, I think part of their rationale was basically just creating a rough course material right at the surface to deter as they're burrowing or moving along, that they wouldn't want to go there. But you know, I really didn't focus on that much when I was talking with them. And like Ben said, I think the moisture retention honestly may be the greatest benefit of it. You know, we don't know, but that seems to be you know, a positive dynamic there. And I would think that the 18-inch diameter at least is better than nothing. If herbicide's not an option or other options aren't there, I will be certainly curious to see how these sites do in coming years, because we know that you've got to give it a few years to really see what takes. And we'll certainly be monitoring that, and we can share that with everybody. But that's a good question.